here's your homework assignment for section 3-3 in geometry. You'll note that there's a lot of text here and not many diagrams. So I'll add the diagrams on the right, but also, just so you know, there will be a quiz on 3-1 to 3-4 as soon as you finish 3-4 and have asked any questions that you need for any of these first 4 sections. So we have some information about a new town that is getting built. In this new town, all the streets will be avenues or boulevards. The avenues will all be parallel to one another. The boulevards will all be parallel to one another. In the middle of the town, Center City Boulevard will intersect Founders Ave at right angles. So, which of the following statements must be true? That is, there are no counterexamples, and justify each answer. So, here's the diagram. Center City and Founders Ave. Let me label these. There we go. Okay. So now every time there's a new street that goes right-left, it will have to be parallel to Center City. And I can make that note by showing you the same arrows. Then all of the streets that get constructed north-south will be parallel to Founders Ave. Okay. So now then we have the first statement. Every avenue will, let me also note that these are the boulevards and the purple are the avenues. Okay, so every avenue will be perpendicular to every boulevard. That means these will be perpendicular, these. Is that true or not necessarily? That is true. Because anytime we have these that are perpendicular that we know of right here, Founders and Center City, anytime we have another parallel line, this purple line would also have to be perpendicular to it. It feels a little like transitive property, doesn't it? Now, is it true that all the city blocks will have to be the same size? Not necessarily. They might be, but even in the diagram, I can have parallel lines that are this far apart and other ones that are still parallel but closer together. So that means that the block size, this size right here, won't be the same for all of them. Will they be rectangular? Well, now here's the thing. We need to define rectangle once and for all. Rectangle is two sets of parallel lines that meet at 90-degree angles. So, square is a special rectangle. We're not saying they have to be square. They just have to fit this description of two sets of parallel lines that meet at right angles. That is true. Number 4, all city blocks will be bordered by 2 avenues and 2 boulevards. Well, here are the avenues, the purple. So this block has one avenue and another avenue, and one boulevard and another boulevard. So number 4 is true. All city blocks will be bordered on one side by city center or Founders. Well, that's not true because I can be down here. Center City is way up here. That's not one of my east-west roads. Founders Ave is over here, and that's not one of my north-south roads. So this would be untrue. Okay, next. We're given a whole list of parallel lines in number 6, and we have to figure out if any of them would be parallel to each other. Well, from the theorem 3-9 that you just were learning about in the notes, you know that if one line is parallel, if 2 lines are parallel to a third line, then the first 2 have to be parallel. So here we go, transitive property at work. A parallel to B. All right, so here's A, here's B. They're parallel. B parallel to C. Oh, I could put it down here, or I could have put it up top, no problem. C perpendicular to D. And D parallel to E. And I'm going to use 2 sets of arrows for D and E just so that we don't get it confused. Now, what are the relationships and how are they related? How are lines A and E related, rather? So, I just drew the diagram according to what was here, and now I need to know what's the relationship between A and E. Can you tell me what it is? That's right. A perpendicular to E. Because I knew that if C was perpendicular to D and D is parallel to E, then C has to be perpendicular to E. And if C is perpendicular to E and A is parallel to C, then A has to be perpendicular to E. New diagram for number 7. A perpendicular to B. So here's A, here's B. I will show that they're perpendicular by these little little squares. B parallel to C. And some arrows to show parallel. C parallel to D. D perpendicular to E. So here's D perpendicular to E. So the relationship that came from here for A and E is perpendicular again. Next. I'm sorry, I just realized I highlighted the wrong line for that conclusion, so let me do number 7 over again. There we go. Try that again. A perpendicular to B. Here's A, here's B. That shows perpendicular. B parallel to C. I show that with arrows. C parallel to D. I'll put that over here. And D perpendicular to E. Here's D, here's E. Now the question is, for all of these, how are A and E related? That's better. So they must be parallel. Okay, great. Now let's move on. Number 8. New diagram. If you want to pause the video and sketch this out for yourself, please do so. A parallel to B. B parallel to C. Oh. Try that again. C perpendicular to D. And D perpendicular to E. So, the question, how is A related to E? They will be parallel. Number 9. A perpendicular to B. B parallel to C. C perpendicular to D. And D perpendicular to E. So here's D, here's E. And the question, how are the A and the E related? Yep, perpendicular. Number 10, A, perpendicular to B, B, perpendicular to C, C, perpendicular to D, and D parallel to E. A must be perpendicular to E. Oops. Number 11, A, perpendicular to B, B, perpendicular to C, C, perpendicular to D, and D, perpendicular to E. Oops, sorry. Here was the C, perpendicular to D. Now D, perpendicular to E. And the relationship between the A and the E is parallel. Okay, new stuff. Suppose you're given information about a sequence of lines L1 through Ln, I don't know how many there are, so let's say n, and the following form. Now, each time you see a box, it's either a parallel or it's a perpendicular. So now, how can you decide simply by counting the number of perpendicular statements in the given information? So it's sort of this chain rule idea from this one to this one and this one to this one. How would we walk through this? Well, if the number of perpendicular statements, if we have an even number of perpendicular statements, so what we're trying to do here is say, let me take all of this and rewrite it over here. L1, let's say we use a bunch of perpendiculars first. L2 is perpendicular to L3. Let me stop there. So L1 perpendicular to L2. Here's 1, here's 2. Now if 2 is perpendicular to 3, that means that 1 and 2 would be parallel, right? So the first one that I drew and the last one makes the whole thing parallel. What if I add one more perpendicular? Well, L3 perpendicular to L4. Alright, well, here's 1, here's 2. So I got this one. Now let me add this statement. 2 perpendicular to 3. Got it. Now let me add this statement. 3 perpendicular to 4. So here's 3 perpendicular to 4. Hey, anytime I've got 3 perpendiculars, that makes the first one perpendicular to the last one. This intersection right here. If you added one more and had an even number of perpendiculars, 1, 2, 3, 4, guess what? An even number of perpendiculars makes the first one parallel to the last one. So here's one way you can write this. An even number of perpendiculars makes L1 parallel to Ln, whatever the last one is. But if I had just an odd number, like these first 3, I'm sorry, an odd number of perpendiculars in this statement, that would make L1 perpendicular to the last one, the first one perpendicular to the last one. Now, if these were all parallels, that actually doesn't change anything. So now, watch this. I'm going to continue with these statements so far and add one more. L4 parallel to L5. So hang on, let me highlight the ones that I'm using. L1 perpendicular to L2, L2 perpendicular to L3, L3 perpendicular to L4, L4 parallel to L5. Does this make a difference when we use a parallel sprinkled in here? Well, here's a new diagram. L1 to L2, L3 to L4, I'm sorry, L2 to L3, 2 to 3, 3 to 4, here's 3 to 4. And then if we said 4 parallel to 5, 4 parallel to 5, here's line 5, that ends up being perpendicular to the first one. So, having a parallel in there didn't make any difference on the beginning versus the end. It just depends on the number of perpendicular relationships you've got. When there's an odd number, you end up with the first is perpendicular to the last. When you have an even number, you have first parallel to the last. Number 13. Theorem 3-10 says that in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. So, here's a line, it's perpendicular. Here's another line, it's perpendicular. So, they must be parallel. So it takes 3 lines to get Theorem 3-10. What are some ways to prove this without using corresponding angles? Ha! Well, we've already done that. What if we said these 2 lines are perpendicular and these 2 lines are perpendicular? And I'm going to draw that note out here. So I know this is 90 and I know this one is 90. Hey, these would be alternate exterior angles that are congruent. So, lines must be parallel. You could also use alternate interior. You could also use, let's see, same side interior. These would add up to 180, of course, and not be congruent. Anytime we're doing same side, we are talking about supplementary. When we do alternate and corresponding, we're talking about congruent. So, you could use any of those methods here. Number 14. In 3 dimensions, is it possible for lines L1, L2, and L3 all to intersect at one point such that L1 and L2 are each perpendicular, but L1 and L2 are not parallel or perpendicular to one another? Well, I don't know if my sketch will help, but let's try. We need L1 and L2 are both perpendicular to L3. So I'm going to do L3 going up and down, straight in the plane of the screen. And now I need L1 perpendicular to that. Okay, so that's going right, left in the screen. Then I need L2 to also be perpendicular to line 3. This is the arrow, this is the 3. Here's line 1. So I need to draw this as something that is 3-dimensional. So let me see if I can do it with the help of some technology. So the thicker line is going to be coming out of the screen at you, and then getting thinner and thinner and thinner as it goes into the screen behind you. So this would be line 2. Now, the idea was we needed 2 to be perpendicular to 3, but 1 and 2 weren't supposed to be parallel or perpendicular. Well, we definitely can't have them parallel because we're trying to go three-dimensional here. But the question is the angle between 1 and 2, as it's getting smaller and smaller, is that angle 90 degrees? Well, we're not sure. From this diagram, it kind of looks 90 degrees, but you could actually shift this line a little bit and end up with something a little more like that. So let's skip this red line and use the blue line for angle 2. And then we can say that no, these are not right angles right in here, nor are they parallel. So yes, you can do it, and the diagram shows you how. Thanks for tuning in. Quiz coming up after section 4.